Yeah. Namaste students. Welcome back to Sumanth tutorial. See here, in this session, I'm gonna solve a test paper for the ICSE grade 10, and the content I have selected here is refraction through the plane surface and refraction at the plane surface as well as refraction through lens that comes under the light unit. See the most important concept under the light heading chapter number 4 and 5. Together I just made for 25 marks. The maximum marks was awarded here is 25. I have divided into two sections, section A and section B. In a section A, 15 marks and section B 10 marks. And here you can see in a section A 15 marks, and it is a compulsory that you have to attend all the question, and the questions are too good. I will solve slowly with explanation. I request you to stay to the end and watch the video completely so that if you got any doubt with the light unit, it will be clear, and the questions are too good. Once again I'm telling, so it is very easy. So I will give you a clear instruction how we are gonna solve it, and that may help you to solve in the examination too. So let's start. The first question is MCQ1. Choose the correct option from the following, and the question is like this. A ray of light passes obliquely from an optical medium of refractive index 1.33 to another medium of refractive index 1.52. While passing from the first medium to the second medium, the light ray will. Now see here, it's very clear, direct question, but two things you should remember here. One thing is the refractive indices of the medium here, and from which medium to which medium the ray of light is passing. These two are most important. Why? Because see here, as you know it very clearly, the ray of light is moving from the medium which is having more refractive index than the previous one. And see here, let me write here medium 1 and medium 2. See here, the refractive index of the second medium is more, means the ray of light, its speed decreases, therefore it bends towards the normal. That's the direct answer. The answer is it bends towards the normal. Here in the question, always remember you should consider two things. One is, let me circle it out, the refractive indices, as well as from which medium to which medium the ray of light is moving. These two are most important. So based on that one, we can easily write as the refractive index increases, the speed of light decreases, therefore it bends towards the normal. That's clear. Then go to the second question. Now see, the second question is like this. There are two convex lenses P and Q of focal length 0.5 meter and 0.4 meter respectively. Which of the following is true about the combined power of the two lenses? When we are gonna keep two lenses together, the combined power, see, it's very clear. Let me write here very simple. So if you want to calculate the power, you should add the individual powers, that's it. And how to calculate the power? We know the power formula, power is 1 by F. Sure. Now see here, let me solve here. See, P1 will be 1 by F1, which is equal to 1 divided by 0.5. Nothing but 1 divided by 5 by 10, which is equal to 10 by 5. So it is 2 diopter. Likewise, the power of the second one, 1 divided by f2, 1 divided by 0.4, so which is equal to 1 divided by 4 by 10, nothing but 10 by 4, so it is 2.5d, right? So what is the sum? 2 plus 2.5d, see here. So let me substitute here. So 2.0 plus 2.5, it is 4.5 diopter. So it is equal to 4.5. That's it. So the answer is A, which is equal to 4.5 diopter. Clear up. Clear? It's a direct question. One thing is you should solve once. By solving, by practice, automatically it will become easy for you. Now let's go to the next one. So see here, MCQ number 3. When light enters from air to glass, when a light enters from air to glass, it bends towards normal. Obviously, it's a statement one. Now see here, if we have selected these three lines, which are these three colors, red, blue and yellow colors are allowed to enter the same glass block at the same angle of incidence, then for which color the value of I minus R is greater? See here, to solve this one we should use our trick. That is, see here, when I compare with the wavelength, red light has the maximum wavelength, and blue has least wavelength, right? And then it is very clear for which color of the value I minus r, angle of incidence minus angle of refraction, is greater. Obviously it is blue color. It is blue color. Okay, now so as the ray of light bends, here the conclusion is, as the wavelength reduces or decreases, the bending of the light will be maximum. If the wavelength is least, it bends for the maximum. That's the reason blue color, the I minus I, blue color, for the blue color it is maximum. Next, assertion and reasoning question. Question number 4. Sometimes the sky appears reddish in the evening. That is true. That is true. Red, being a longer wavelength, scatters more than other colors. Now see here, up to this statement it is right. Red being longer wavelength, we know it, but scatters more than other colors, this is wrong. Right? Then it is very clear, answer is very clear. Assertion is true, whereas reason is false. To solve assertion and reasoning type of questions, so first read the statement very clearly and slowly, then you can able to understand the content. Now go to the last MCQ. The distance V of a virtual image formed by the lens of focal length 15 centimeter never exceeds a certain finite value, then the value will be. Now see here, when it is the fact of finite value, when the question is occurs with the finite value, remember only a concave lens we can expect it, not with respect to convex. If you ask me, sir, how it is possible, answer is very simple. So if you are going to get the image distance to be a finite with respect to the virtual one, it is concave, it is fixed. Now, if you observe the ray diagram, the image will gonna form in between the object and the lens. You know it very clearly. So the answer is D, less than or equal to 15 centimeter. Like this, we should solve with respect to the MCQ one. See here, answers are maybe tricky, but if you know the rules, if you know the content, then it becomes very much easy. Now go to question number 2. As I followed the board pattern, in the second one it is like fill in the blanks with options like 2 or 3, depends on the question. Now see here, complete the following by choosing the correct answer from the bracket. First thing, when a ray of light travels normal to the given surface, then the angle of refraction is normal to the given surface. The ray of light travels normal to the given surface, angle of incidence is 0, as well as angle of refraction is 0. We call it as normal incidence. It is normal incidence, right? So when a ray of light travels normal to the given surface, we call it as normal incident, then I will be equal to, R will be equal to 0 degree. Another name for it is normal incident. Now the second question, reflection or refraction is the phenomena of apparent bending of a pencil when it is partially immersed in a water. Obviously, reflection won't come here. The answer is refraction. This is the right one. Answer is a refraction. Now the third one. Diamonds sparkles due to the phenomena called as TIR, total internal reflection. Here also the direct question. So this is because of total internal reflection. Now the last one, concave lens produces only virtual image. It cannot produce a real image, so it is virtual image. Now see here, observe these four questions. These four questions are very direct questions. In exam also they will ask like this only. It will be a direct question. A little bit trick will be there. Read the question slowly, keep your mind calm, read the question, then you can able to crack it very easily. Now this is 4 marks. It is there in your pocket now. So totally you have 9 marks. Now go to the next question, that is 2 marks set. See here, write any two factors affecting the refractive index of the material. See here only you need to list. So what are the two factors? First is nature of the medium. Nature of the medium, you know it very clearly. Another one is angle of incidence, and also you can write here temperature. Okay, angle of incidence will come, sorry. And you can also write wavelength. So these are the things that you can write. The factors affecting the refractive index, nature of the medium, temperature, wavelength, like that you can write here only two. Any two you need to list out. So you select and you write. No need to explain anything. Directly you write which are the factors on which it affects. That's it. Then go to the next question. One more question. Where should an object be placed in front of a convex lens in order to get an enlarged real image? So this is in between f1 and 2f1. Remember this one. So you are gonna place the object between f1 and 2f1 to get enlarged image. Don't get confused. There are two kinds of things. One is enlarged, another one is highly enlarged. So highly enlarged is at f1, but enlarged means between f1 and 2f1. Next thing is sorry, enlarged virtual image. So that is in between f1 and optic center. f1 and optic center. These two you should remember. Clear? Now, question number 4. Why can we not use concave lens for reading? Why can't we use it? So it's very clear. So what type of image size we may expect in a concave? So see here it is virtual. Obviously when it is size comes it is diminished, right? The image formed is diminished. For a reading glass we need a magnified image, isn't it? So for a reading purpose we need the image to be magnified, not diminished. Means it's very clear, in a concave lens there is no chance of getting a magnified virtual image. That is the reason we cannot use concave lens as a reading lens. That's it. Okay, then one more question added to it. See here, which lens have more focal length, thin lens or thick lens? Usually students get confused with this one. It's very clear. Thin lens have more focal length. Thin lens are more focal length than thick lens. Answer is very simple. As the lens gets thinner, its circumference will be more, means the focal length is maximum. That's the reason if the thickness of the lens decreases, its focal length increases. It is inversely proportional. So this is section A. Up to here we are dealing with 50 marks question. Next is section B. attempt any one, means there will be a 2 questions. Out of 2 questions, you are going to attempt any one of it. It is like 3-3-4 bold pattern only. So let me explain the question. A type of glass block has a refractive index of 1.8. Calculate the speed of light in this glass. See, direct question it is. So it is 2 marks question actually. So the formula is mu is equal to C by V. So let us substitute the value. 1.8 is the value of mu. C value they had not given, but it is basic. It is 3 into 10 raised to 8 divided by the value of V. Or if I take the value of V, it becomes 3 into 10 raised to 8 divided by 1.8. And you know it very clearly how to solve it. See here, V is equal to, here 3 ones are 3, 18 is 0.636, right? 0.6 can be written as 6 by 10. So it is 10 divided by 6 into 10 raised to 8. So here it is 2 5s are, 2 3s are, then it is 3 1s are, 5 is 3 1s are 3.2, then 3 20, it is 3 6 18, 3 6, so obviously so it is 1.67, 66 it becomes 67 into 10 raised to 8 meter per second. So this is the value of V, means the speed of light in that particular glass will be 1.66, or you can write 1.67 into 10 raised to 8 meter per second. If you solve this one, you will get 2 marks. So this is for the question number A. Now let's go for question number B. What it says: if the width of this block which we are using is doubled, then what will be the speed of light in the block? No change. No change. There is no change in the speed of light. As we know it very clearly, the speed of light does not depend on the thickness of the glass slab. Here there is no change. Clear? So if you solve this one, you will get 3 marks. I think this question is clear to you. Now let's go to the next question. That is question number 4. This is a numerical one, 3 marks. What it says: a convex lens of focal length 10 centimeter placed at a distance of 60 centimeter from the screen. How far from the lens should an object be placed so as to obtain a real image on the screen? It's a direct question. Now see here, the value of F is given 10 centimeter and the value of V is given, that is 60 centimeter. We are going to calculate the value of U, and the formula is 1 by F is 1 by V minus 1 by U. Next is substitution. 1 divided by 10 is 1 by 60 minus 1 by U. Now transpose 60 to the other side. So 1 by 10 minus 1 by 60 is minus 1 by U. For 10 and 60, LCM is the 61. 10 table 6 are, 6 table 1s are, it is minus 1 by U. Or 6 minus 1 is 5 by 60 is minus 1 by U. Right? Or U is equal to minus 60 by 5, and the value of U is 5 12s are 60, right? So it is minus 12 centimeters. See here how easy it is. So here one thing, whenever you are gonna have the question based on your U, V and F, one thing is sign convention. You should remember the sign convention, followed by while reading what's the value it is given in the question, that you have to check. Here 10 centimeters is the focal length, 6 centimeters the image distance, and we are going to calculate the object distance. So U is equal to minus 12 centimeter. Clear? So let's scroll down. Go to the next one. Yeah, see here, this is diagram based question, and this question is carrying 4 marks. What the question says? The diagram below shows an object AB kept in front of a lens. A path of ray coming from the object is shown. This is the diagram. So name the lens. Now see here, observe this part as it is converging. So the lens is convex. 1 mark. If you write convex, you will get 1 mark. Now redraw the diagram to show the formation of an image. I already selected the diagram which has written here. The most important thing where the student needs to concentrate, that I will say. See here, observe this part. So this is the dotted line. It is compulsory. That shows it's a virtual part. And see here, the image is also written in a dotted line only. Magnified virtual image in a convex lens is the most important thing. So while you draw the ray diagram and you have mark here L, but in examination if you write like this, please specify it as convex lens or concave, depends on the question. So which type of lens it is, that you have to specify, otherwise you are going to lose the mark. Sure, I think that diagram is clear. So this is for 2 mark. Then what's one more mark question? Yeah, it is here. See, in which optical instrument this kind of image is formed? Answer is very simple. It is magnifying glass. It is magnifying glass. In a magnifying glass, we are gonna see this type of arrangement. Clear? You are gonna write the answer as magnifying glass. Sure? I think you are clear with the content. Right, this is the most important. So here you can get 10 marks after solving this one. Then go to the last question. It is the optional one as we know it. So let us solve this one also. See here, this is the question, so I need some space to solve it. Let me push this one to the next. Yeah, now the question is like this. Question number 4. Sita needs a lens of power minus 5D for correction of her vision. What is the possible vision defect of Sita? See, it's very clear. Power is negative, then focal length is negative. The lens used is concave, so she is suffering from myopia. She is suffering from myopia, or you can write it as short-sightedness. Short-sightedness. These two are important one. See here, application in that part you are gonna learn in defect in eye. Short-sightedness, myopia, long-sightedness, hypermetropia. The correction lens for myopia is a concave lens, and for hypermetropia is convex lens. So how to identify which lens it is? Based on the power. If the power is negative, the lens specified will be concave. If the power is positive and the lens doctor which is going to specify it will be convex. Now see here. Here the answer is myopia, 1 mark. Now what is the focal length of the correcting lens? Now see here. We are going to use the formula. Power is inversely proportional to the focal length, or the focal length is inversely proportional to the power. See here, it is minus 1 by 5. Sorry, yeah, it is minus 1 by 5. 1 by 5 is 0 0.2. It is minus 0.2 meter, or you can write, not you can directly write as equals. So minus 0.2, which is equal to 20 centimeter, like this. You can 0.2 if the rate, that is enough. So this part is for 2 marks, and the previous question number A. So this is for B. For 2 mark, A is 1 mark, total it is 3 marks question. Now see here, this is the most important question mark here. Important one. I'm gonna teach how to redraw it. See, the question is like this. The diagram given below shows a glass prism of critical angle 42 degree. They have marked here also the critical angle is 42 degree and the ray of incidenting PQ. Redraw and complete the path of ray PQ till it emerges out of the prism. See here the diagram which look like this. How the ray diagram that we can write that I will teach here. Now listen, for the time being just observe this. Now see here, you can see it is a triangle, right? Angle of incidence directly, so normal incidence it will gonna reach up to x. Now see here, this is 90 degree, this is 90 degree. Then first calculate what about this angle. So here see 48 plus 90, so it is 138. So 180 minus 138 is 42 degree. So here the angle formed is 42 degree. So usually when the student had seen this one, what they will do, they are gonna write like this and they will say that it will retracing the path, but it is wrong. Why it is wrong? This 42 is not the angle of incidence. This is not the angle of incidence. Angle of incidence is the angle formed between normal and the incident ray, right? Then now how to calculate what is the angle of incidence? See here, normal line always forms 90 degree. Normal line always forms 90 degree. If one of the angle is 42, another is 48. Another is 48, greater than critical angle. So see here, I is greater than critical angle, then obviously total internal reflection will gonna occur. At this point, total internal reflection. Therefore, at x, the ray of light total internally reflected and reaches Z. See here, at Z, see here you can write this is 48 means this is 48 obviously, so this becomes 42, right? And this is 90, and see here this is 48 and here 42. 42 is critical angle, that is the reason it retraces the path at this point. See here, I is equal to C critical angle. At Z it is critical angle, at X it is total internal reflection. The most important and easiest way so that you can redraw the diagram. See here, this is a most beautiful diagram. So if you know how to construct it, then pakka you will get 3 marks here. Done? Okay, then go to the next question. So this is 4 mark question, I think. Redraw the diagram. No, it is 3 marks question. Yeah, 4 mark question is here. So this is for 3 marks question. Be careful here whenever you are writing. See here the angles you must write, and I had shown. No need to by heart. No need to mug up the things. If you know the content easily, you can score and easily you can write. Do not mug up the things. Practice, it's logic, just use the logic, you will get to know that one. Then the last question, this is for 10 marks. Let me push this question down here. This is 4 mark question. What it is showing, an aquarium made of glass is filled with water. A small object is kept at the bottom of the aquarium. You observe the object from above through and water. You are given with a refractive indices. What's the value? 1.33 and 1.5. Assume the actual depth of the object in the water is 30 centimeter. So what we are going to do? We are going to calculate the apparent depth from the surface explained by the object is closer than it actually is. If the aquarium had no water but only the glass, how would the apparent depth change? See, it's very simple. Use only one formula. So I will guide you. You solve it. See here, use the formula mu equals C by B. That's it. Okay, sorry. You cannot use C by B. Oh, sorry. Mu is here real depth by apparent depth. Sorry for my mistake. So we are going to use real depth by apparent depth. First, for water, they are given here. Let me write. For the water, mu value is 1.33 is equal to what we have to calculate the apparent depth. Now, here real depth is 30 divided by apparent depth, or the apparent depth will be equal to 30 divided by 1.33. How much you will solve? That much of centimeter. Very simple. Done. Now the second question. Explain why the object appears closer than it looks because of refraction. You must explain the concept based on refraction. Now, if the aquarium had no water but only glass, it is completely glass made one, then how the apparent depth changes? Here also please use the same formula. Mu is equal to real depth by apparent depth. For here, for glass, so what's the value they have given? It is 1.5. Now see here, 1.5 is equal to 30 divided by apparent depth, because actual depth will not gonna change. Then apparent depth will be equal to 30 divided by 1.5. How much will you get? That much of centimeter is the answer. Then finally you are going to compare it. So what happens if it is with the water? What happens if it is completely with the glass? See here, student. This is 25 marks based on the right unit, and the content is too good. And the question is too good. I think you people got to know how to solve the question. So keep in touch. If you have not subscribed, please subscribe Sumanth tutorial. Next onwards, like this question, I'm gonna meet you very soon. Till now, take care. Bye bye.